everybody, and welcome back to another Algebra 1 video. Today we'll be finishing up Chapter 5 with Lesson 5.6 on Arithmetic Sequences. A sequence is an ordered list of numbers. So for example, this would be a sequence here below. Each number in a sequence is called a term. So for example, 5 would be a term, 10 would be a term, 20 would be a term, and so on. Each term is going to be referred to by a subscript n. This basically just represents any term that is in your sequence. And each term an is going to have a specific position n in the sequence. So this is what the subscript n represents. It's going to be the specific position. And when we're talking about specific position, we're just talking about where it is in the order of your sequence. So for example, 5 would be in first position. That's because it is the first term in your sequence. And 20 would be in fourth position. 15 would be in third position, because again, it is the third term in your sequence. And so as you keep going on in your sequence, an just represents any term in the nth position. And so there's just a short introduction to what sequences are, and as we move into examples, it will all start to come together. So what is an arithmetic sequence specifically? Now, what we were doing in the previous slide was just introducing sequences in general, but an arithmetic sequence is a specific kind of sequence where the difference between consecutive terms is the same. This difference is going to be called your common difference, and each term is found by adding the common difference to the previous term. So for example, if you have 5, 10, 15, and 20, to get to 10, you're adding 5 to 5. To get to 15, you're adding 5 to 10. To get to 20, you're adding 5 to 15. And so you see you have a constant common difference in your sequence of plus 5, and that is going to be your common difference. Also, just a side note, if you're wondering what consecutive means in this situation, consecutive just means following. So the numbers that are next to each other. So for example, 5 and 10 are consecutive terms, 10 and 15 are consecutive terms, and 15 and 20 are consecutive terms. And that's just to clarify if you're a little bit confused by what they mean by the common difference between consecutive terms. But now we're going to look at a few examples using what we know about our common differences, and we're going to try and extend an arithmetic sequence by finding the next 3 terms. So we're already given a part of a sequence right here, -7, -14, -21, and -28. These are 4 given terms, and we just have to find the 3 next consecutive terms. So first thing you want to do is you just want to find your common difference. And so how much is being added or subtracted between each of them. And once you find that, you can go ahead and keep using that common difference to find your next 3 terms. So to get from -7 to -14, you're subtracting 7. From -14 to -21, you're subtracting 7 again. And to get to -28 from -21, you're subtracting 7 once more. And so now we've established that our common difference is -7. So now to get our 5th term, we just have to subtract 7 from -28. So -28 minus 7 is going to give you -35, and that's the first term that you're looking for. And then subtract -7 from -35 again, and that gives you -42. Here's the second term you're looking for, and do that once more to find the 3rd term. And so -42 minus 7 would give you -49, and so these are the next 3 terms that you are looking for. So all we're doing here is finding the common difference and then applying that to find our next three terms. And now we have a bunch of different arithmetic sequences that we can work with. And so we're doing the exact same thing that we did in the last problem. So if you're feeling comfortable with how to do this, feel free to pause the video and unpause just to check your answers. And if you still feel like you want to get more practice, then go ahead and feel free to continue with this segment of the video. And so for this first sequence, we have -12, 0, 12, and 24. And so from -12 to 0, to get to 0, you're adding 12. And to get from 0 to +12, you're also adding 12. To get from 12 to 24, you're adding 12 once again. And so now we've established we have a common difference of 12. All you have to do is keep adding 12 to your consecutive terms to get your next three terms. So from 24, you want to add 12, so 24 plus 12 will give you 36, and this is your first term of the three we're looking for, so keep adding 12, 36 plus 12 will give you 48, and the last term we're looking for, 48 plus 12, will give you 60. For our second sequence, we have 0.2, 0.6, 1, and 1.4. So first let's go ahead and find the common difference. 0.2, you add 0.4, and you get 0.6. Between 0.6 and 1, you're adding 0.4 again. From 1 to 1.4, again you're adding 0.4. So we have established that 0.4 is our common difference, and so we can just keep adding 0.4 to each of our terms until we get our next three terms. So 1.4 plus 0.4 gives you 1.8. 1.8 plus 0.4 gives you 2.2. And 2.2 plus 0.4 will give you 2.6. And so there are your next three terms. And for our last arithmetic sequence, we have 4, 3 3/4, 3 1/2, and 3 1/4. So let's go ahead and first find our common difference. And so looking at our sequence, to get from 4 to 3 3/4, you're actually going to subtract 1/4. And to get from 3 3/4 to 3 1/2, you're also subtracting another fourth. And to get from 3 1/2 to 3 1/4, you're subtracting 1/4 again. And so you found your common difference to be -1/4, and so you can just keep subtracting 1/4 until you get your next three terms. So 3 1/4 minus a fourth would just give you +3. And then 3 minus 1/4 would give you 2 3/4, and then 2 3/4 minus a fourth will give you 2 1/2. And so there are the next three terms of your arithmetic sequence. Now that we have a better grasp on what an arithmetic sequence is, I wanted to go ahead and move into the equation of an arithmetic sequence. And so first I wanted to model an arithmetic sequence on a coordinate plane and graph it just to see what you notice. And you'll actually see that an arithmetic sequence is in the form of an equation that we've been working with a lot. So let's say we're graphing the arithmetic sequence for 8, 12, and 16. The way you want to plot your ordered pairs is n, remember that's the position of your term. So for example, 4 would be your first term, 8 would be your second, 12 would be your third, and 16 would be your fourth. And a sub n just represents your term. So for example, 4, 8, 12, and 16. And so if we were to organize our ordered pairs in a table, your position n is going to be like your x values, 1, 2, 3, and 4. And then your term, a sub n, is going to be your corresponding y value. And so if we were to plot these ordered pairs on a coordinate plane, let's go ahead and see what happens. So we have 1, 4 for our first ordered pair. The point would be there. 2, 8, 3, 12, and 4, 16. Now, what do we observe? Our points actually lie on a line, and so this means that in arithmetic sequence, his equation is actually linear. And you'll see that it looks very similar to a lot of the linear equations we've been working with. So here is the arithmetic sequence equation format. It's a sub n equals a1 plus n minus 1 times d. And you want to make sure that you try your best to remember this because it's going to be very useful throughout this chapter. And so because consecutive terms of an arithmetic sequence have a common difference, the sequence has a constant rate of change. And you might recall this constant rate of change from lesson 5.5 because that's what we were looking for in our linear equations. The way we identified whether a linear equation was linear or not is to see that it had a constant rate of change in both the x and y values. And so the points of any arithmetic sequence are going to lie on a line. You can use the first term and the common difference to write a linear function that describes an arithmetic sequence. So this is, once again, our arithmetic sequence equation. A sub n is basically just any term that is in your arithmetic sequence, and we refer to this as the nth term. A sub 1 refers to the first term in your sequence. N is the position of the term, so remember a term can be first, second, third, fourth, just depending on where it is in the order of your sequence. And then minus 1 times d. And d is going to be your common difference, and that's going to be that constant rate of change that we were looking at in the first few examples. Here is our first example. We're going to write an equation for the nth term of the arithmetic sequence 14, 11, 8, 5, then find a sub 50. And so first thing you want to know is the arithmetic sequence equation. Remember, it's a sub n equals to a1 plus n minus 1 times d. And so what you want to do is looking at the given values you have for your arithmetic sequence, you want to go ahead and plug in any information you already know. So we know that a1 is going to be our first term, 14, and we can actually find our common difference, d, just by looking at our terms here. So from 14 to 11, we're subtracting 3. From 11 to 8, we're subtracting 3. And from 8 to 5, we're subtracting 3 once again. So we know that our common difference is negative 3. And so you're actually not going to be plugging in anything for a sub n or n, because remember, we're just writing an equation for the nth term. So you don't have to substitute anything for these, just for a1 and your d value. And so if you substitute those two values, you have a sub n equals 14 plus n minus 1 times negative 3. And so now we can simplify. First thing you want to do is get rid of your parentheses. So you want to distribute your negative 3 into n minus 1. And so that would give you 14 plus negative 3n plus 3. And now you can combine like terms and simplify further. So 14 plus 3 would give you 17. And so your final arithmetic equation is going to be a sub n equals to negative 3n plus 17. And so here is your equation for the nth term of the arithmetic sequence that we're given here. And actually, if you were to, say, plug in 1 for n to find the first term, you'd see that it should equal 14. So negative 3 times n for 1, negative 3 plus 17 would give you 14. And so that's how you can have a method for checking whether your equation is correct or not. And so now we can move on to part 2, which is finding a sub 50. And so remember, a sub 50 just means we're trying to find the 50th term. And so all that means is that we need to substitute 50 for our n value. So we're looking for the 50th term of our sequence. And so a sub 50 equals to negative 3 times 50 plus 17. Negative 3 times 50 is negative 150 plus 17. And if you simplify that, that just gives you negative 133. And so your 50th term would be negative 133. And something to note is that you can basically substitute n for any value. You can find the first term, second term, 500th term, as long as you have your correct equation, and you'd be able to find any of the terms in an arithmetic sequence. And so here's another problem very similar to the last one. We're going to write an equation for the nth term of the arithmetic sequence, and then find the 25th term. So first, let's go ahead and write down our arithmetic sequence equation. A sub n equals a1 plus n minus 1 times d. So now we can go ahead and plug in any of our known values. So we know a1, which is our first term, is going to be 8. And then we can go ahead and find our d value, which remember is your common difference. And so from 8 to 16, you're adding 8. From 16 to 24, you're adding 8 once again. And from 24 to 32, you're adding 8 once more. So you know that your common difference is positive 8. So now you can go ahead and substitute those values in. Remember, you don't have to substitute anything for a sub n or n, because again, you're just trying to write an equation for any of the nth terms of the arithmetic sequence. So now you can go ahead and continue to simplify. First thing you want to do is get rid of your parentheses, so distribute the 8 into your n minus 1. That will give you 8 plus 8n minus 8. And then you can go ahead and simplify further, so 8 minus 8 actually cancels out, and that would just give you a sub n equals to 8n. And so that would be your equation for the nth term of the arithmetic sequence. And so now you can use this equation to find any term in your arithmetic sequence. In this case, we're going to find the 25th term. And all you have to do is substitute 25 for your n value. Remember, n just represents the position in your arithmetic sequence. So in this case, we're looking for the term in the 25th position. And so all you have to do is substitute 25 into n. And so 8 times 25 would equal to 200. And so now you know that the 25th term of this arithmetic sequence is equal to 200. Now we have another arithmetic sequence equation that we're going to be writing, except now it's formatted in a word problem. And so an online bidding for a purse increases $5 for each bid after the $60 initial bid. So we're going to write an equation for the nth term of the arithmetic sequence. So looking at our information, we see increases $5 plus 5. And so now I'm thinking that increases 5 plus 5, that means that's probably our common difference. And so $60 is going to be our initial bid. So since it's initial, I'm thinking that's going to be your very first term in your arithmetic sequence, and from there it only increases by 5. So you want to go ahead and substitute those values into your arithmetic sequence equation. And so I would substitute 60 for A1 and then 5 for D. And now we have 60 plus n minus 1 times 5. Now you can just simplify. First I'm going to go ahead and distribute 5 to our n minus 1. That's going to give me 60 plus 5n minus 5. and further simplify, 60 minus 5 would give you 5n plus 55. And so your final equation for the nth term of the arithmetic sequence is a sub n equals to 5n plus 55. And again, with this equation, you can go ahead and find any term in any position for your arithmetic sequence. And so part 2 is that the winning bid is $90. How many bids were there? And so rather than trying to find a certain term in the arithmetic sequence, they've already given us the term. So all we have to do is take the equation we found. And so remember, that would be a sub n equals 5n plus 55, and we're trying to look for the value of n when a sub n equals 90. So the number of bids refers to the position of the term in your arithmetic sequence. And so since you're already given the term, a sub n can just be substituted for 90. So 90 equals 5n plus 55. You're looking for n. So first you want to subtract 55 from both sides to isolate n. That would give you 35 equals 5n. And to completely isolate n, you want to divide both sides by 5, and n will equal to 7. And so that means that there were 7 bids, and the 7th bid is going to be your winning bid of 90. And so if you were to look at that on an arithmetic sequence, your 7th term would be 90. And so that is it for today's video. Thank you so much for watching. As always, if you have any questions, please feel free to reach out to me via email at kaelin.david24@gmail.com. I'm always checking my emails, so I'll be sure to get back to you as soon as possible. And all information regarding private tutoring, lesson requests, and additional practice can be found linked down below in the description box. Again, thank you so much for watching. Please make sure to subscribe and like this video if you enjoy the content, and I hope to see you on the next one.